Hi, I am Dr. Shobhan Kumar DM, working as assistant professor in Maharani Science College for Women. Now, I welcome you to DC Digital Learning Sessions. Dear students, we have to discuss finite differences. What do you mean by finite differences? Here, in this concept, first we know the introduction. Numerical analysis provides approximate solution for all types of problems like linear, nonlinear, ordinary differential equation, partial differential equation, and integral equations, and so on. Numerical analysis does not strive for exactness. Instead, it yields approximations with specified degree of accuracy. In this section, in this session, we have to discuss basic concept of finite difference with equal intervals. First, we know the meaning of finite difference. Suppose we are given the following values of y is equal to f of x for a set of values x. Here x equal to x0, x1, x2, and so on xn. Y is equal to y0, y1, y2, and so on yn. Here x are equally spaced. X are equally spaced with step length or with width h. Here h is the width of the interval or step length of the interval. Then the process of finding the value of y corresponding to any value of x, in generally xi, between x0 and xn is known as interpolation. Interpolation means you have to estimate the value of y in the interval of x is known as interpolation. Thus, interpolation is the technique of estimating the value of a function for any intermediate value of the independent variable, while the process of computing the value of the function outside the given range is known as extrapolation. Extrapolation means the estimate the value of y outside the interval is known as extrapolation. Now, the study of interpolation is based on the concept of differences of a function, which we proceed to discuss. Suppose the function y is equal to f of x is tabulated for the equally spaced values x equal to x0, x0 plus h, x0 plus 2h, and so on x0 plus nh, giving corresponding values of y is equal to y0, y1, y2, and so on yn. To determine the values of f of x or f dash of x for some intermediate values of x, the following two types of differences are found useful. One is forward difference, another one is backward difference. Forward difference, the difference y1 minus y0, y2 minus y1, y3 minus y2, y4 minus y3, and so on, yn minus yn minus 1, when denoted by delta y0, delta y1, delta y2, delta y3, and so on, delta yn minus 1, respectively, are called the first forward differences. These are first forward differences, where delta is the forward difference operator. You should remember, delta is a forward difference operator. Thus, the first forward difference is delta yk. In generally, delta yk is equal to yk plus 1 minus yk, or delta yn. Delta yn is equal to yn plus 1 minus yn. Okay. Similarly, second forward difference is delta 2yk is equal to delta yk plus 1 minus delta yk. This is known as second forward difference, delta 2yk. Similarly, we can write down nth forward difference. Nth forward difference is defined as delta nyk is equal to delta n minus 1 yk plus 1 minus delta n minus 1 yk. Defines the nth forward differences. This is the nth forward differences. These differences can be represented in the form of a table, is known as forward difference table. This is nothing but forward difference table. In a difference table, X is called the argument. Here, whatever we can write down X, no, these are the argument, or Y's are called entries. Y are called entries and X are called arguments. X are called arguments. And the first entry is known as a leading term, and delta y naught, delta 2 y naught, delta 3 y naught, and so on. These are known as leading differences, forward leading differences. Okay, leading differences. Now we know how to write the forward difference table. Okay, here first we have to write values of x, arguments. Here x, should remember x are equally spaced. Here x naught plus h, x naught plus 2h, x naught plus 3h, x naught plus 4h, and so on, x naught plus nh. Here we have to stop here, x naught plus 5h. Okay, here 6 arguments here. And corresponding values of entries are nothing but y's, y0, y1, y2, y3, y4, y5. Now we have to find the forward differences. Here y1 minus y0 is delta y0, delta y0. y2 minus y1 is delta y1. y3 minus y2 is delta y2. y4 minus y3 is delta y3. y5 minus y4 is delta y4. These are known as first forward differences. Okay, is to know forward differences. These are known as first forward differences. Now I have to find second forward differences. Delta y1 minus delta y0 is denoted by delta 2y0. Delta 2y0. Delta y2 minus delta y1 is denoted by delta 2y1. Delta y3 minus delta y2 is denoted by delta 2y2. Delta y4 minus delta y3 is denoted by delta 2y3. These are known as second forward differences. Second forward differences. Similarly, third forward differences. Delta 2y1 minus delta 2y0 is denoted by delta 3y0. Delta 3y0. Delta 2y2 minus delta 2y1 is denoted by delta 3y1. And delta 2y3 minus delta 2y2 is denoted by delta 3y2. These are known as third forward differences. And fourth forward differences are delta 3y1 minus delta 3y0 is denoted by delta 4y0. Delta 3y2 minus delta 3y1 is denoted by delta 4y1. These are known as fourth forward differences. And finally, delta 4y1 minus delta 4y0 is fifth forward difference, is denoted by delta 5y0. Here, xi's are called arguments, y's are called entries, and delta y1, delta y0, delta 2y0, delta 3y0, delta 4y0, delta 5y0. These are leading forward differences. These are very, very important. Okay, these are forward leading differences. Now we know some properties of delta, forward difference. Here delta of a f of x plus b g of x is equal to a into delta f of x plus b into delta g of x, because here a and b are constant terms. Take it outside and applying delta operator on f of x and g of x. Okay, delta m of delta n f of x is equal to delta raised to m plus n f of x. And delta f of x equal to 0, where f of x is constant function. F of x is constant function. And another one, delta f of x into g of x is equal to f of x plus h delta g of x. You should remember, delta f of x into g of x is defined as f of x plus h into delta g of x plus g of x into delta f of x. And the last property is delta of f of x by g of x is equal to g of x delta f of x minus f of x delta g of x divided by g of x plus h into g of x. Here f of x and g of x are two functions. This is the forward difference table and its properties. Next, we have to discuss backward differences. The difference y1 minus y0, y2 minus y1, yn minus yn minus 1 are denoted by nabla y1. Here, instead of delta, we can use nabla. Nabla is the backward difference operator. Delta nabla y1, nabla y2, and so on nabla yn respectively are called the first backward differences, where nabla is the backward difference operator. Thus, the first backward differences are nabla yk is equal to yk minus 1. Similarly, second backward difference is nabla 2yk is equal to nabla yk minus nabla yk minus 1. In generally, nabla nyk is equal to nabla n minus 1 yk minus nabla n minus 1 yk minus 1 defines the nth forward difference. This is nth forward difference. These differences can be represented in the form of a table called backward difference table. Here we know how to write the backward difference table. This is similar to forward difference table, but in this table, here nabla y4, nabla 2y3, nabla 3y2, nabla 4y1, nabla 5y0 are the leading backward differences. This is the only difference between forward difference table and backward difference table. In forward difference table, I have to consider these are the forward leading differences. In backward, these are the backward leading differences. Okay, here these are the arguments, entries, and first backward differences are y1 minus y0 is nabla y0, y2 minus y1 is nabla y1, y3 minus y2 is nabla y2, y4 minus y3 is nabla y3, y5 minus y4 is nabla y4. Okay, similarly, second backward differences are nabla y1 minus nabla y0 is nabla 2y0. Nabla y2 minus nabla y1 is nabla 2y1. Nabla y3 minus nabla y2 is nabla 2y2. Nabla y4 minus nabla y3 is nabla 2y3, and so on. Okay, these are the backward leading differences. Now I have to discuss some examples. Construct forward difference table for the following data and find the value of delta square y0 and delta cube y1. Here table is given, x and y's are given. Here arguments are 0, 1, 2, 3, 4 and y, 8, 11, 9, 15 and 6. Now we can write the table. First forward difference, here x and y, x 0, 1, 2, 3, 4 and y 8, 11, 9, 15, 6. Now we can write down y1 minus y0. This is y0, y1, y2, y3, y4. y1 minus y0. That means 11 minus 8 is 3 is delta y0. This is a delta y0. And 9 minus 11 is minus 2 is delta y1. 15 minus 9 is 6 is delta y2. 6 minus 15 is minus 9 is delta y3. These are the first forward differences. Delta y0 is equal to 3, delta y1 is equal to minus 2, delta y2 is equal to 6, delta y3 is equal to minus 9. Now we have to write the second forward differences. Delta y1 minus delta y2. That means minus 2 minus of 3 is minus 2 minus 3 is minus 5. And 6 minus of minus 2 is 6 plus 2 is 8. Minus 9 minus 6 is minus 15. These are the second forward differences. This is delta 2 y naught, delta 2 y1, delta 2 y2. And again, next forward difference. 8 minus of minus 5 is 8 plus 5 is 1, 3, 13. Minus 15 minus 8 is minus 23. These are the next forward differences. That means third forward differences. Here delta 3 y naught is 13, delta 3 y1 is minus 23. And next forward difference, fourth forward difference is minus 23 minus 13 is minus 36. This is delta 4 y naught. Okay, delta 4 y naught. Now in this problem, find the value of delta 2 y naught and delta 3 y naught. Here from this difference table, delta 2 y naught is minus 5. This is delta 2 y naught, delta 2 y naught. This is a delta 2 y1, delta 2 y1, delta 2 y1 is 8. Okay, delta 2 y1 is 8. And again, this is a delta 3 y naught. This is a delta 3 y1. Delta 3 y1 is minus 23. This is the required solution. Next problem is construct backward difference table for the following data and find the value of nabla 240 and nabla 350. Nabla 240 and nabla 350. It can also define it as here x are given x naught, x naught, x1, x2, x3, x4. Here, this is x3. Here, instead of nabla 2y40, it can also give on nabla 2y3. Nabla 2y3. Okay, nabla 2y3 is nothing but x3, y of x3. Here, x3 is equal to 40. And nabla 3y50, it can also written as nabla 3 y4, y4 because x0, x1, x2, x3, x4. Nabla 3 y of x4. Okay, not the same. Now I have to how to write the backward difference table. First, you can write down the x in first column, y's are in second column. Here argument x equal to 10, 20, 30, 40, 50, and so on. And corresponding values of i's are 1, 1.3010, 1.4771, 1.6021, 1.6990. Now I have to write first backward differences. This is y0, y1, y2, y3, y4. y1 minus y0, it gives delta y0, sorry, nabla y0. 1.3010 minus 1 gives 0.3010. 1.4771 minus 1.3010 gives 0.1761. 1.6021 minus 1.4771 gives 0.1250. 1.6990 minus 1.6021 gives 0.0969. Here, this is a nabla y0, nabla y1, nabla y2, nabla y3, nabla y3. And again, second backward differences. 0.1761 minus 0.3010 gives minus 0.1249. 0.1250 minus 0.1761 gives minus 0.0511. 0.0969 minus 0.1250 gives minus 0.0281. These are the second backward differences. Second backward. This is a nabla 2y0, nabla 2y1, nabla 2y2. And next, minus 0.0511 minus of minus 0.1249 gives 0.0738. This is nothing but nabla 3y0. And minus 0.0281 minus of minus 0.511 gives plus 0.0230. This is nothing but nabla 3y1, nabla 3y1. And next backward difference is 0.0230 minus 0.0738 gives minus 0.0508. This is nabla 4y0. Here you should remember this is a nabla y0, nabla y0 or nabla y1, one are the same. Nabla y1, this is a nabla y0. It can also written as nabla y of x0, or it can also written as nabla y10. This is a nabla y20. This is a nabla y40. This is a nabla y50. And here nabla of 2y10, nabla 2y10, nabla 2y20, nabla 2y40. This is a nabla 3y10, nabla 3y10, nabla 3y10, nabla 3y20. This is a nabla 4, nabla 4, nabla 4, y10 in forward, in backward. Here, this is nothing but nabla y50, nabla y50, nabla 2y50, nabla 3y50, nabla 4y50, because this is a backward difference table. You should remember, okay? This is a nabla y50, nabla 2y50, nabla 3y50, nabla 4y50. Similarly, this is a nabla y40, nabla 2y40, nabla 3y40. Therefore, here from this table, nabla 2y40 is equal to nabla 2y40 is equal to minus 0.0511, and nabla 3y50 is equal to 0.0230. I hope you're all well understanding the forward difference and backward difference. Now we have to discuss some problem. Here evaluate delta of log x. Delta of log x. Here we know the property. Delta of f of x is defined as f of x plus h minus f of x. According to that, here f of x is log x. Therefore, delta log x equal to log of x plus h minus log x. Here it can also written as log a minus log b is log a by b form. Log of x plus h divided by x. Here and again x by x plus h by x. X get cancelled. Log of 1 plus h by x. Therefore, delta log x is equal to log of 1 plus x h by x. And similarly, you have to discuss here y is equal to x cube plus x plus 1 for x equal to 0, 1, 2, 3, 4, and hence find the values of delta 2y2 and delta 4y0. First, you should construct forward difference table and then write these two values by using the table. Next problem is evaluate delta of e raised to 3x log 4x. Here we know the property delta of f of x into g of x. Here f of x is e raised to 3x and g of x is log 4x. Here f of x is e raised to 3x, g of x is log 4x. Now using this property, delta f of x, g of x equal to f of x plus h into delta g of x plus g of x into delta f of x. Here according to this, here f of x is e raised to 3x, replacing in e raised to 3x, x by x plus h. We get e raised to 3 of x plus h into delta log of 1 plus h of x, because we know the one more property. Delta g of x is equal to g of x plus h minus g of x. Simplify that. Here already we simplify in earlier problem. Here delta log x. Delta log x is nothing but log of 1 plus h by x plus g of x, you can write down as it is log 4x, log 4x, log 4x. Here into delta f of x. Same property we can use. Delta f of x is And again delta f of x is f of x plus h minus f of x, and simplify, we get e raised to 3x into e power 3h minus 1. Therefore, delta of e raised to 3x log 4x is e power 3x into e power 3x 3h log of 1 plus h by x plus log of 4x into e power 3h minus 1 minus 1. I hope you are all well understanding these two differences. One is forward difference table and another one is backward difference table and its properties. These are the references. If you're interested, you can go through these references. Okay, now let me stop this stage. Okay,